start recording before I forget that. And also let's do attendance. Oop. And we can begin if we're all doing okay. All right, so today we are going between two sets of slides. We're going to finish up these ones with the very last part being about evaluating and controlling technology because it has such a force on our lives these days. And then we'll start some new slides as well. So let's dive right on into it. I'm going to try and talk to this idea. So technology, we love it, but it has some downsides, right? Your essay that you're working on. How can I cope with them? Like, how can I still wake up in the morning and also think critically about them? Because that's what this class is about. So let's have a bunch of little examples of several things that are weird in terms of technology, and let's talk about them. So have you all heard about this thing called deepfake before? This idea where, oh man, we can take videos now and change the sound or change the faces. It's really, really fancy, and if you've never heard of it before, deepfaking is when you use machine learning techniques to swap these things. Usually it's faces, right? To swap faces in a video so it looks like somebody else was there instead of who really was there. And this isn't like a new idea, right? We've always had Photoshop, and that's become a verb. So if you Photoshop something, it means that you've made it look like something else, right? But this has never really been a thing until deepfake came along for videos. We could usually trust like a surveillance video, right? From a security camera. A video used to be pretty good proof that somebody was in some place and that they did that thing, okay? But nowadays we can change those faces in every little frame of a video and make it look like somebody else was there. I think when I stole all these pictures from the internet, everybody really wanted to change everybody's face to Nicolas Cage, but that might be a past fad now. So yeah, this is nowadays, it could be used for fraud, it could be used for hoaxes, right? To make it look like some famous celebrity was somewhere, they did something that they didn't do. And of course, I'm sure there's a pre-programmed deepfake package that you can download to put Nicolas Cage in every video. That's always nice. But yeah, that's new, right? That's weird. We can't trust videos anymore, just like we can't trust images anymore. How do we know if somebody actually did something? Maybe they wrote about it on Wikipedia. Maybe there's an article. Can we trust that? Do English teachers these days still not like Wikipedia? Is that a thing? Okay, yeah. Back when I was in school, it was like, and it first came out, that was like very, very contentious. And I'm glad to hear that it's still a thing. So let's talk about it. Wikipedia is nice because it has so much information and it's able to update itself very quickly because anybody can edit it, right? You can make an account and add your take on something as long as you cite your sources. So people are adding new stuff, new articles every day. Like maybe the article used to not have a picture, you can go in and add that picture, or somebody can, and update it. Maybe there was only this much text before, but now you can add this much text because a new article came out about this topic. That's really nice. So everything can change. New information can be added to every Wikipedia article, and as soon as new things happen, the Wikipedia places, or the Wikipedia pages, change. That's really nice to have, right? That is like, it is the best. It's the ultimate news article because it links to all the others. But there are some downsides there too, right? And this is what maybe our English teachers are worried about. Anybody can modify a Wikipedia article, right? I can change it. It's totally fine. Like I can go, if I wanted to get my account banned, I could go like to the page on Queen Elizabeth or something and make her picture my cat. That would not last very long, but I could go and do that, right? That's totally possible. You can edit any article with your account. Some accounts are locked to only like trusted accounts, but not most articles are like that, are locked off. Anybody can edit. And what does that mean? Like, does that mean we can't trust it? What do we think about this? Please shout out with any comments or questions that you have. But at least as far as Wikipedia goes, they understand that this is going to happen a lot. They like to scan every new edit and new change to every article and make sure to automate the easy stuff. Like if people start adding a bunch of bad words or hot topics that are irrelevant, they immediately remove those edits and don't allow them to happen. But more subtle edits can take place. And sometimes it means that a human needs to look at that thing and make the change and notice that it really was incorrect. Okay? Other times, like articles are incomplete and they have all those citation needed links all over the place, showing that the article is not of very good quality, but it's still a good source, right? We have to somehow weigh these two ideas, these two competing ideas of whether or not we should be using Wikipedia. Does that mean we just shouldn't use it at all? And this is kind of my take on it, and I think most English teachers' takes on it too. As long as you look on Wikipedia first, that's fine, but that shouldn't be your only source, right? As long as you do your own research and like look at the citations, go to the articles that are being cited on the Wikipedia page and read those and make sure that they're being summarized correctly and that you understand them. Cite the cited articles. Don't cite Wikipedia, right? That's the idea. So that is my spiel on Wikipedia and the pros and cons of it. Any ideas, any thoughts about that? One day I was on Reddit for just some weird reason, and they linked to a page for like the California grizzly bear. I have no clue what I was looking at, but I clicked the link. I'm like, I want to learn about grizzly bears. And then immediately once I clicked on it, I saw that it had been edited. Isn't that crazy? Somebody had gone along and added that sentence at the very start of it. And so I quickly took a screenshot and added it to this slide so that I could give it to you guys this semester. But yeah, this kind of stuff is just common, and it gets flagged pretty quickly and it gets deleted. It happens all the time. So yeah, I just have a bunch of little examples for the rest of these slides before we start our new ones. Let's talk now about simulating car crashes, because this is very important. We all drive most likely, and we want our cars to be safe, right? I'm pretty sure to have a car be sold in the US, you have to have a car crash test done on it somehow, maybe multiple. I'm not sure of the particular rules, but I think we can all agree that it costs a lot of money to do a car crash test. You have to make the car, right? You have to sacrifice one of your models, and that's quite expensive. So why not? How about we just make a simulation of a car crashing into a wall? That's a lot cheaper to do, right? How about we do that in software? So turn this fancy physical model of our car. That's a horrible drawing of a car. Let me try and fix this. So it's got a front, it's got that. Yeah, there we go. Got some wheels. And it's got like a dummy inside. And then they're going to speed it into that wall, right? That is somehow 3D. Okay, so why not just transform all of that to a computer simulation? What could go wrong? Have it all happen on a computer. What needs to take place in order to do that is probably the first question. So if you want to do this, if you want to test a car crashing simulated, you have to essentially play God, right? You have to make physics simulated in your little computer. You have to model every detail of every material, every metal, everything that takes up the car. You have to model that. And it's actually not too bad, right? Like video games these days have great physics modeling. We know a lot about how to make it all realistic and modeled well, but it's never perfect, right? We can't model every individual atom in the car and see what's going to happen to it. That is impossible. That would take too much computational power. But it's still useful, right? Maybe. And so the idea here is that if you write a simulation you're forced to simplify the way that the car looks, right? You can't talk about every individual metallic atom. You have to simplify it into chunks, maybe, inside of your simulation. And that means that your simulation isn't perfectly accurate anymore, right? Is that okay, is the question. Should we be doing this? Maybe they should be just testing real cars in real life so they know exactly what's really going to happen. Because you can't mess real life up in a real life crash test. So I thought of two arguments for this, and I think you might believe both of them. So one argument for these car crash tests is the idea of them being a supplement to the real ones. Because maybe, I think that they're forced to eventually perform a real car crash test and show that people are going to be safe if their car crashes into a wall, right? So eventually they're going to do the real test, and it's only better for them to perform simulations before that real crash test, because then they can test any assumptions that they had, right? They can maybe make a better car because they'll run more tests in total by simulating hundreds or thousands of those crashes. So maybe it'll be safer in the long run. That's a possibility. So that's an argument for those simulations. An argument against, though, is, well, they're simplifying inside of those simulators. So maybe if they just would have fronted the money and crashed 100 real cars, they would have found a better and safer design. So what do we think? Should they be doing this? Should they not? That's what I want to get you thinking about. Any questions, comments about these ideas? I just have a bunch of these little examples. Shout out if you feel strongly about something. Yeah, that seems like a good middle ground, I think. I sure hope whoever's making the laws in the U.S. are like forcing them to do a certain number of real crash tests. But I'm not really sure. That's definitely not my area. Any engineers in the house? Maybe you would know. Yeah. Any other comments before I talk about something completely different? Because all these are different ideas. Same theme, though. We all have phones, most likely. So Google, if you have an Android phone, they can delete any app that you have on your phone, assuming it's connected to the internet, right? Which it usually is eventually going to be. Google can remotely delete an app from your phone if they don't like it. They have the power to remove stuff that you downloaded from your Android phone. Is that okay? The whole idea behind that, of course, is to protect the end user, the people who are downloading these apps. Maybe they didn't know that they downloaded something that was bad. It was a malicious app. So Google goes and deletes that for you. But that's kind of a slippery slope, right? Should they even be allowed to do that in the first place? That's something that you maybe paid for. Maybe it was an app that they didn't like. It's totally possible for them to go and delete it, right? Should they be allowed to do that? They totally can right now. I think this is a common thing among all the phone operating system makers, but it's more common among Google, as far as I have read. Apple has done this too. They can delete things, but it is very... I didn't see as many articles about Apple doing this as I saw about Google doing it. So it's possible. Anybody has control over your phone in addition to you. So let's talk about Apple in a different light, because I guess it's not as recent anymore, recent to last semester. So recently, did you remember this article in the news? Like Apple took off, they banned the game Fortnite on iPhones, on iOS. They took it off the App Store. Everybody who had already downloaded it, they got to keep it, which was nice. So they didn't like steal it from the people who already had it. They didn't steal it away, but they took it off of the App Store because they were breaking the App Store rules. They did not want to give Apple a 30% cut of their subscription fees. That is a thing that Apple takes from every developer. That's a pretty large cut. And so those video game makers didn't like that. And people like Netflix and maybe other apps, I can't remember, they kind of made custom deals with Apple that didn't require this, and so there's a lot of controversy. But this is a thing. Is that okay? Should they be taking money? That much money? And then if they don't give you that money, should they remove the app from the App Store? That's a crazy rule, maybe. So, yeah, the reason behind this is those terms of service. If you're going to be a developer and make an app on the App Store, you have to follow those silly rules, whatever that might be. And if you don't, your apps can totally be removed, either from the App Store if you're just not giving Apple enough money, or from users' phones if there's something malicious going on with your app. Okay? So again, this is kind of a slippery slope. Who's to say that Google won't take away an app one day that is really, really nice, but harms their business in some way? Hopefully they won't. They'll catch a lot of flack for it, but they could right now. And then my final funny example is Amazon makes those Kindles where you can read stuff. They can remotely delete things too, and they deleted 1984 from customers' Kindles once upon a time. Just that book. So that was funny. So should we give people control over things that we have already bought? That's the question. That's what I want you to think about. All right. If we must use Windows, sometimes we are unhappy with it. Do you guys remember the controversy over if you had a Windows 8 computer, it would automatically update to Windows 10 without asking you? That used to be a thing. So, oh yeah, 7 to 8. 7 was much better. That is exactly right. Yeah, so they have a long history of doing this. That's unfortunate. I'm trying to hold off on Windows 11 for a little bit, maybe until the end of the semester. So, yeah, that's a thing. Somebody that you bought something from is allowed to tell you what version you can use, and they will update it for you automatically. Doesn't that mean we're losing control of what we have on our computers? Like, why don't we get to make that choice? Why is someone else making it for us? And again, there are arguments either way. An argument for Windows being automatically updated for you to a major version is the idea that a lot of computer users aren't very computer literate, right? I would want my parents' computer to be automatically updated because Windows is pretty notorious for getting a lot of viruses, right? So it's older software. The reason they're updating it most of the time is because there's little security holes in it. And so it's easier to exploit. Wouldn't it be nice if those updates could be automatically given out to everybody so that their software is more secure and their computer will be much happier, right? It won't try and steal their bank account information. So that's one argument for forced upgrades. But again, the argument against is that you've lost control over something that you probably spent money on, right? Even if you buy a computer, if it has Windows on it, you've spent a little bit of money on that operating system. And so you have lost control over what's going on. All right. Questions, comments about that? I have 2 more slides in these slides. Then we'll talk about more bad things. All right. The last thing that I would like to talk about is just, I don't think it's anything that any one company has done, but it's a theme. Let's talk about equity. Do we know the difference between first, like the idea of equity versus equality? This is like the standard picture that everybody shows. Equality is people everybody gets a box to stand on, but equity is everybody gets the boxes that they potentially need to stand on in order to have the same experience. We can talk about equity and technology at the same time. So if you think about the pandemic, a lot has happened regarding technology. It has become a lot more important in a lot of people's lives because maybe we all have to work remotely now. So if somebody belongs to a low-income household, it's very likely that they do not have as much money to buy a computer, a nice computer, or a fast internet connection that could help them, especially during the pandemic, with employment. Yes? For example, like if you don't even have a phone right now, or an email address because you don't have an internet connection, and you can't afford it, that means you can't get an interview somewhere. Usually you have to apply online these days and give an email address and make an account, right? That's what I had to do to apply to this job. It's crazy. You need all those things. What if you couldn't afford it? So again, yeah, this idea is very important during the pandemic because everything requires computers these days. Like, I'm sure you've maybe taken a math class that had to use that Proctorio or whatever, right? If you don't have a webcam, you can't take that class. It was simple as that, right? Luckily here, at least we're giving out those things, but I'm sure there are a lot of other students at other places that were less fortunate, and that's really not okay. So, yeah, we want to think about this, and I want to get it in the back of your minds, because one day maybe you'll be a software developer. Think about equity with respect to technology. Because even when you're making a program, you might not do it equitably, right? A lot of the time, people make programs and they're sitting in their fancy San Francisco offices testing the program on the people who work there, which are predominantly white people. That is unfortunate because a lot of those like facial recognition technologies, they don't work well for somebody of a different race. It's really not okay. So yeah, even if somebody buys that fancy technology, maybe it wasn't tested on people like them. Maybe it won't work for them. That's unfortunate. And I found a nice tweet in that regard about somebody who was using some kind of proctoring software, and it said that they had poor lighting in their room, even though they did not. Their skin was just darker. That's really not cool, right? So definitely test your programs equitably if you ever become a software developer. All right. So yeah, social issues with technology. Any last comments before I switch gears into a different set of slides? All right. Here we go. Let's talk about more bad things, but just a different theme. Let's talk about risks, the risks of using a computer, and some bugs, some unfortunate things that have happened that weren't really planned. It was just an accident. Some accidents happened, and sometimes they're really bad accidents. All right, so let's talk about those. So my first little subsection, which is the one I think we'll do today, is errors, failures, and risks. Let us begin. So I guess we are in a computer science class, so maybe we're a bit biased, but let's try and talk about like why are we still using computers? They've done some horrible things to people. Why do we still care about them? We have our reasons, right? So, true. That is true. Perfect counter-argument. All right, so let's talk about a rocket first. This was the Ariane 5 rocket. It was made by the, if I zoom in here, can I? Boop. It wasn't made by NASA, it was made by ESA? I think they just called themselves ESA. It's the European Space Agency. So they made a rocket to do what rockets do, right? Send probably satellites into orbit, things like that. And the first time they launched their Ariane 5 rocket, it did something horrible. It did not work out very well. It was unmanned, so nobody got hurt, but their rocket self-destructed back in '96, 37 seconds into the flight. That is unfortunate. It decided to blow itself up because something went horribly wrong. And it wasn't a mechanical failure. It was just a little accident, a badly written line of code, essentially. Just a little software bug that could have been avoided. And ESA lost $370 million after 37 seconds. Crazy, huh? So that's the cost of the rocket, the cost of all the things that were on it that were supposed to go into orbit, all the satellites probably. Let's talk about what went wrong. Why did software cause this rocket to explode or to trigger its self-destruction phase because it thought something was extra wrong when really wasn't? So here was the problem. I think we have enough information now to fully understand it, which I'm excited. Like, I can talk about cool computer science concepts and you can understand it now. So what they did is, remember the difference in types between Python numbers? You can have your floats, which have decimal places and dots and can be large. And you also have ints, which are whole numbers only. Yeah. So they tried to shove a float and put it into an int, which is going to cause problems in the first place, right? It's going to chop off information because ints can only hold whole numbers. Maybe it rounds it, but still it's not the same number anymore. So they tried to transform a floating point number, float, remember it's cloud, the float cloud, like 3.14. It could be giant numbers like, I don't know, 5 times 10 to the 50. That's totally possible in float land. But ints can only hold whole numbers, and they have a range. Got your 42, got your 0, got your negative 42. Those are all possible. And there's like a maximum int that you could hold and a minimum int that you can hold. Same for floats, but it's a lot bigger of numbers. Okay. Another thing having to do with types is the size of the types. So we talked about binary. I think you can imagine, even though you're not sure, I haven't told you how floats are encoded in binary. How do you make ones and zeros have decimal places and exponents? It's totally possible. And floats were stored as 64 bits in the software. That's the standard way of storing floating point numbers. Just a bunch of ones and zeros, 64 bits long. 64 ones and zeros long. Remember what bit means. It means binary digit. So they were storing information in a 64-bit float, and they were trying to put it into a 16-bit int. That is 1/4 of the size. Yeah. So that smells like trouble, right? So that's the first problem. 16 bits. I think we can all agree that you can shove more stuff in 64 bits than you can in 16. So, yeah, I think I hopefully have explained what they were trying to do, because I've told you all of those words, but maybe not what they meant together. So now that's what's happening. What the issue was the number that they were trying to convert was a very important number from their sensors. It represented the horizontal velocity of the rocket. Okay, so let me try and show you what that means. So here's Spain, Italy, blah, blah, blah. Here's the UK. Poop. So there's Europe. And here is the rocket taken off. It's going up. It's a little, I don't know, it's a cylinder. It's shooting off. And horizontal velocity, I assume, means relative to Earth. So it's like, if you could draw a little triangle with what direction it's going relative to Earth, that would be horizontal velocity. Like, it's trying to go that way, essentially, but away from Earth at the same time. So that's what horizontal velocity means. And that number, the horizontal velocity of the rocket, what's called overflowed. Okay? That is a new term. That means that there was not enough numbers. Technically, yes. There was not enough room to store that converted number in the right way. So let me try and, maybe I'll use a different color because I've got a lot going on this slide already. Let's talk about overflowing. So let's say that we have only, we're using 4-bit numbers. We can only store things as 4-bit numbers, so we can go between 0000 and 1111. Those are all the numbers that we can use. So what does that mean? Let's say that we had this number, 1111, and we tried to add 1 to it. Let me show you binary addition. These are all base 2, base 2, base 2, base 2. Watch what happens. I'll teach you binary addition right now. 1 plus 1 in binary is 2, which is 1, 0, so you have to carry. Boop. And then we have 1 plus 1 again. That's also 1, 0. We have to carry because it's 2. 1 plus 1 again. 1, 0 we have to carry. 1 plus 1, 1, 0 we have to carry, but there's nowhere to carry 2. We only had 4 bits to work with. Do you see how we couldn't store that bigger number in that many bits? You only have a fixed size inside of a computer. So there was supposed to be a 1 here, but we had to chop it off. That's what overflow means. We tried to represent a number that could not be represented. There wasn't enough room to store that number properly. So the issue was, finally, in full, that they reused the code. It's called Ariane 5, right? They reused their code from Ariane 4. And back when they wrote Ariane 4's flight control software, they thought that that horizontal velocity number would never get so large so that it would overflow. Bad idea, because apparently Ariane 5 went a lot faster than Ariane 4. It's cooler. So, moral of the story, if you're going to reuse software, maybe run a simulation, maybe make sure it's going to do the right thing. So that was a very, very expensive problem, and it went down to only one variable, right? The horizontal velocity variable inside of their program was the one issue. And because it thought that that number was so small, it thought that it was stalling probably the rocket. And so it's like, all right, I'm just going to blow myself up because I don't want to hurt people. I don't know where I'm going right now. I might fall. So, yeah, a software bug that cost almost $500 million. Yay. Any questions about that idea? That's a fun little story. So that happened. Another idea. Let's talk about voting systems. I'm sure most of us are of age, right? So we have likely voted before. Boop. When you have an electronic voting system, which is not very common, if maybe illegal in California, things can go wrong. So here is some things that went wrong from your textbook. So back in the day, some electronic voting systems, because they're electronic, they're prone to failure, right? You can't really mess up a piece of paper, but you can totally mess up some electronics. Voters then, who wanted to vote, could not vote. That's not good. Hopefully they had a backup. That's a possibility when you have electronics, isn't it? And then you can have errors, which sounds really shady, right? Shady and sketchy. So one county who was trying to tabulate their votes and hold an election, they lost some votes because there wasn't enough RAM inside of their voting machine, apparently. There wasn't enough memory or maybe disk space to store all the votes of all the people who came and used that machine. So they lost those votes. Oh man, that's not okay. In another county, an error in the voting software, because it can always come down to software again, a programming error, probably very benign and simple looking, just hard to find, it generated 100,000 extra votes, probably just for one person. I don't remember, but I assume it's that. And that's really bad. Hopefully somebody auditing the election noticed it and just threw those out. But that's really unfortunate, right? Those are the kinds of things that can go wrong. And it happens. It really does happen. Probably the most horrible was this one. Another bug in the software caused the wrong candidate to get the votes. So it saved the votes properly. There was enough memory. Every person, it was one vote to one person, perfect. But every person didn't get who they voted for. So the programming error, the bug, caused some candidates to receive votes actually cast for other candidates. And so they lost out on representation that way. I'm not sure how they figured that out. That's a really cool thing to notice. Probably a very hard thing to notice. That's no fun. That's probably why in California we still use paper and humans. So yeah, it's really hard, right? The moral of the story is it's very hard to write software that's good, right? That's correct, that really will do the right thing all the time. And for certain things like aviation, for voting, you need that software to work perfectly. It needs to be battle tested. That needs to be a thing. And I'll talk about that maybe not this lecture, but next lecture, how to make perfect software. There are ways. Yeah. Some other countries even have like flocked to electronic voting. Like in Estonia, you can vote completely online with your probably passport number or whatever they have there. Should that be a thing in the US? Maybe if there weren't enough bugs, that could be possible. That would save a lot of people time having to go to the polls. All right. Any questions about this idea before I go to the idea that you are hopefully already acquainted with? The machine I'm asking you to write your essay on. Okay. Let's talk about the Therac 25. Did we read the article? All right. So this guy was a radiation therapy machine. So if you had cancer, you would go and sit for a while and have this machine try and target with radiation wherever the cancer was in your body, right? So radiation therapy machine controlled by a computer. So you could program the spots on the body where it should fire its radiation, right? And this machine first came out in 1982. And the first time people really documented and noticed when bad things happened was 1985. So it was out for 3 years, maybe a little under 3 years, before they really noticed that something was wrong. So it could have been causing problems, and it probably was that whole time. That's not good, okay? I assume we all understand how bad radiation can be, yeah? That is not okay. So let's talk about what went wrong. There are errors in, right, the design of the thing itself and in the code. There are errors in the design and the code of this Therac 25 machine. And those things combined, hardware errors plus software errors, they allowed for that machine to give people 100 times as much radiation as they were supposed to get. And that is the ultimate irony, because you came there to get treated for cancer and it gave you more cancer. That is horrible. So yeah, very, very important thing to talk about. Let's talk about what went wrong, because I know you've read the article. Let's talk about it some more though. So here was the issue. It's, again, a number bigger than 1. So they've had some Therac machines before this one. What happened? Why did this one go wrong? The previous machines, they used hardware fallbacks to block excess radiation. Like, they didn't trust the software. The hardware people didn't trust the software people for the old, like the Therac 24 machine. And so this is my best drawing of, let's pretend this is what a radiation gun looks like. Here's the thing, trying to shoot radiation in the wrong way because there's a software error. When the machine was not in therapy mode, there was like a giant cylinder of lead, most likely, to block it in previous Therac machines. It was like, oh, you're not supposed to be sending this radiation right now. Don't do it. And it made sure that it did not send excess radiation. That's what happened. Even if the software was like, oh, let's send some excess radiation, the hardware fallback blocked it. So that was nice. The issue now for the new machine, for Therac 25, was, again, they used the same code because they thought it worked, right? They thought it worked, but it was trying to, unfortunately, send a lot of radiation when it shouldn't have. And because it worked before, they thought that they didn't need that hardware fallback. And that was incorrect. Okay? So they thought that they could just do it in software, used previous software that they didn't know was wrong, and we ended up with some issues. Yeah? Is that how we interpreted the article? Are there any questions, ideas about that? It's a very, very unfortunate thing that happened. All right. If we're okay with these ideas, what I'd like to do is give you a little debate among your peer instruction group. So please go to the written nice page and I will clear it out. I'll give you some time to think about this next question. Boop. So please, as a group, take some time to discuss this question. So I want you to think about, is it the programmer's fault? Like, somebody wrote that line of code in the Ariane rocket. Somebody wrote that line of code in the Therac machine that caused economic damage and physical damage. Is it the programmer's fault when something bad happens and people get hurt? Think about that question as a group, and then try to come up with one argument for each side. Try to say yes, and here's why, and also no, and here's why. Think about both sides of this argument, please, as a group, and try to write down both of them. So I'll give you some time to think about that and discuss, but that is the idea. Okay, any questions about that? All right, be free. Take some minutes to think about this topic. Then we will discuss.
A simple simulation, throw that into it and see what happens. So there's a lot of things that they could do. I don't think it's the one programmer's fault mostly. I feel like it's more the whole team's fault for not catching it. It's like the group effort, Everything has to be aligned with one another. Someone should have caught it along the way. Yeah, if you have like 40 engineers, and this one piece is like the one key thing that failed. Yeah. Like you have the wrong time.
All right, take about one more minute. Seems that our conversations are dying down. All right, that is my timer. Let's take a look. Are there any groups who have some strong opinions that they'd like to share? Or should I just go through them? Let's randomly scroll up and down. And of course I got nowhere. Never mind. Here's one. Boop. Group 29. Argument for and against the idea of blaming the programmers. So it is the fault because their job is to make the code, right? That was your one job, right? If the code was incorrect, that means they did that thing. They share the blame. So that's a good point. Why wouldn't it maybe be the programmer's fault? Yeah. I'm not sure how familiar we are with like large software companies, but usually this idea of testing is very important. There's a job to be a tester, to be a software tester rather than the person who's making the programs. That is a total thing that exists in industry. Companies often hire multiple, right, tons of testers in addition to just normal programmers. So maybe they should have done that. They should have run some more tests, actually used the machine on a patient, should have been standard practice. And I think this is actually something that they did do, reading the article, right? It took some weird use of the software to cause this issue, right? And so I'm sure all the programmers were using the software in the perfectly correct way, but there was that weird way that caused it to fire the radiation, right? And so maybe the software people shouldn't have been the ones testing it even. Should have been somebody who learned about it some other way. Let's look at group 16. Yeah, why might it be the programmer's fault? Should have been tested. Yeah, that is a problem. Why maybe it's not the programmer's fault is because, let's see, yeah, maybe it's the company's fault as a whole, and that's a strong idea as well. It's not any one person's fault. It's maybe the whole company's fault because they should have had some practice in place where issues like these could have been found and resolved. Yeah. And again, it's often the case, and I think I heard a group talking about this, it's often the case that there are a ton of programmers working on something. And they're all working on their little pieces, and maybe as far as their little piece is concerned, what they wrote was correct. But it doesn't work very well in terms of the big picture of all of their software that all the different programmers are working on coming together. That's another issue and potential idea. Okay? So, yeah, maybe to the programmers, their software was correct, but they just didn't fully understand because maybe they weren't told how it would be used. Okay? That's another thing to think about. Any other groups would like to share? Or are there any comments about this stuff? Because these are good ideas. Dun, dun, dun. As a programmer, you're liable for any flaws in your program. It's your job to make sure the program works. Yes, yes, yes. It is literally your job. So yeah, there are different sides. There's a bunch of sides to this coin, and I think testing was a word that came up a lot. Maybe I've talked about that a lot. Maybe you've heard about it a lot. Maybe it's a natural thing to think about next, but that is a very important idea. Okay, so let's talk about this some more. Here's the slide that I came up with. So yeah, it's always a hard thing to do, especially in a large software company, to assign blame. How does this work? Because people are usually working in giant teams on little pieces of software, right? And they don't fully understand where it's going. That's totally possible. That's most likely the case for this. Okay? And I think we've all been there. We've all written enough programs nowadays to know how easy it is to make a program that doesn't really work all the way. Yeah? You've had plenty of practice with that. So the solution, the main solution we have in industry is testing and verification. Okay? Emphasis on the testing. That's usually the main way of doing these things. Testing and verification are our only hope. And as a speaker of English, you might think that these two words are exactly the same and they mean the exact same thing. In computer science, they do not. Testing is more common than verification, and I'll talk about the differences next time. So the goal is you want to have your little chunks of software that all the programmers are working on. You would like to write tests for each of those. Make sure they're doing the right thing in a bunch of different edge cases and normal cases as well. Make sure they all pass. Like, oh, true, true, true. Yes, they all pass their tests. And maybe another test that brings them all together. Make sure that it does everything that it should be doing properly. That's the idea with testing. Okay? So let me go into a bit more detail there. What we want to do is test all of our code as much as possible, because it is a very easy way to catch bugs. So here's the testing strategy. Let's see here. You have your code. It is a black box. The tester maybe doesn't fully understand it. That's okay. They understand what it's supposed to do. So here's your code. And the idea of a test is, well, your code usually takes some input and produces output. That's what programs do, yeah? So the idea of a test is you give input. Like you give 42 to your code, and it produces some output. Maybe, I don't know, 13. And then the idea of a test was, okay, I'm going to give 42, and I know what the code should have done. I'm going to expect to see 13. That's what a test means. Like, all right, I get 42. I get 13. Check. That test passed. Yeah? And then maybe I give another number like 27, and I see 88. And, oh, no, it was supposed to be 87, so that test failed, and the programmer now needs to go back and fix it. So that's the idea of a test. You give a bunch of input-output pairs that you pre-compute in your mind ahead of time. You know what the software should have done, and you check and make sure it really did that. Okay? That's what a test is. And I think you can imagine that you can't catch every error with testing, but it catches a lot of them. There are ways to make really good tests that will catch every potential error, but they're hard to write. But it's a really good middle ground that's used in industry. Okay? And it's very unfortunate that even in, like, when I'm teaching in my major level CSCI classes, I'm forcing my students to write tests and they hate it. That's just a very common experience among programmers. They don't like writing tests. And hopefully we can one day change that. So here's like an example test. And then I'll go to Scratch, because why not? And we'll write one, and that'll be today. So an example test would be like, try input 42. This is how you write a test. A test is just another program that runs your program. Try input 42 and then confirm. Confirm that the output is 13. And that would be a single test, and you would write a ton of these, trying a bunch of different edge cases, making sure that what you expected was what you really got back. Okay? Any questions about the idea of testing and what it means? Because the very last thing in lecture that I would like to do today, I do also need to remember to release your next essay, because you have one due this week, so I will try and remember that. But before we get there, let's write a program and a test for that program. Okay? So let's make let's go back to Scratch, because I need loops. We don't have loops in Python yet. Let's make a multiply the numbers from 1 to n block. And so, like, you could give it 4, and it would compute 1 times 2 times 3 times 4. Yeah? That's the goal. So that's the program I would like to write, and then we'll write some test cases for that program. So I guess I'll go to Scratch right now. And let's just briefly talk about the strategy. It's the same as like adding a bunch of numbers, right? Instead of summing a bunch of numbers, I'm multiplying them together. So like I'm getting a number from the user, call it n, and like it's set to 4, because that's what the block is running with right now. And then I need some kind of temporary variable that will hold the answer, called like product or something, if I can spell product. And it needs to start at 1 because I'm going to be multiplying a bunch of numbers into it. So it should start at 1 and not 0. And then I'll just repeatedly take my n, put it into multiply product by it. So 1 times 4 is 4. Decrease n, 4 is now 3. Multiply that into product, so now it's 12. Decrease n, multiply that into product, so now it's 24. And then make it 1. I guess we could multiply it into product because why not? Still 24. And then once n becomes 0, that will stop our multiplication loop. And the answer that I give back to the user is the one in product. Yeah. So that is like my program. And then we want to write tests as well. Okay. So let's do that. Dun, dun, dun. Let's see the best way to do this. So Scratch Cat, hello, welcome back to the show. Let us make a multiply numbers from 1 to blank block. Boop. From 1 to. I don't think I want to call it n. I want to use that in this variable. So let's call it, I don't know. Let's call it num or something. That's fine. There. And so if I were to run this code, like multiply the numbers from 1 to 4, here, I'll zoom in. 4. What do I want to happen when I go to this block? Well, I want it to set off the n and the product variables in the right way. So let's just do that quickly. Set, I need an n variable and I need a product variable. So there they are. So the very first thing I'll do is set both of those. Set n to 0, or set n to num, whatever I was given in the block, and then set product to 1 because I want to multiply stuff into it. And then repeatedly, as long as n is not 0, that's going to stop it, right? Repeat until n is 0, a bunch of multiplications. Repeat until n equals 0. Ton of little multiplications. So we want to set product to be whatever it is times n. I'm going to multiply it into product each time. 1, 2, 3, 4 times. Product is whatever it was times whatever n is. And this will all stop when n becomes 0. That will allow us to end this. And then I want to change n by -1. I want it to decrease. So I multiply 3n next, and 2n next, and then 1, and then it never multiplies 0 because that stops this loop. Okay? And then that's essentially multiplying a bunch of numbers. Let's try running this. So product is 24, yay, when it's that. Let's try this one. Product is, when I do 10, product is very large. Is that correct? I don't know. So yeah, that is the idea. 1 to 4, 1 to 10. That is the goal. So, yeah, let's make some tests now, okay? Here's essentially what a test looks like. You compare what you got with what you expected. Yeah? Compare what you got with what you expected. So here are some tests. Like, okay, if you multiply all the numbers from 1 to 4, that should give you back, if 4 was the input, then the output should have been 24. That's a test. If we gave the numbers from like 1 to 1, that should give back just 1. Yeah? That's another test. That's like an edge case. It's like a very simple thing that you could do. Maybe all the numbers from 1 to 2, that should give back 2. And those are a bunch of tests, okay? That's something. So let's try this. Let's just do one of them. So let's multiply the numbers from 1 to 4, and then the testing bit would be essentially an if block. If, because remember, this is messing with the product variable. If product is not 24, then the test failed, right? If it was, it passed. That's essentially how this works. So if product is equal to 24, then we're like, the test passed. Test 4 with 4 passed. Otherwise, the test with 4 failed. And that's a test. So you try the thing, see if it gave you back what it was supposed to give back. So the test with 4, yay, passed. And that is a single test. Any questions about that? So now we need to figure out corner cases, because some tests are better than others. We should be like, let's try a weird number. Let's try normal numbers. You gotta do them both to make sure your code can handle everything. So maybe let's try giving negative 42. Who knows? What's going to happen? What should happen? Like, what does it mean to multiply all the numbers from 1 to 42? Or sorry, negative 42. What does that mean? What should it mean? We're the programmers. We get to decide this. Let's try and run it right now. Like, what's going to happen? We actually have an infinite loop because it's trying to check if it ever becomes 0, and it never is going to become 0, right? Because it's already less than 0. So that's an error. Do we see that? So we tried this corner case, and we ended up noticing that our program doesn't work very well right now. So here's something that you can do. When you have a test like that, maybe you made the test first, in fact. Maybe if you give negative 42, the answer should just be like negative 1 or some error result. That would be a good idea. Let's make it so that, let's design it this way. So if this test passed, we have noticed that we got a bad answer, or a bad input, and we gave back just a silly output that doesn't cause the program to loop forever. Yeah? So that's what we noticed by making our tests and trying a bunch of options. That might have not been apparent before. That's why we make our tests. So let's see what's the best way to change this. If we ever get a negative number, we don't ever want to try this loop. So maybe we could do it this way. We could make sure that n is greater than 0, and if it is, we'll do what we really wanted to do. Otherwise, we'll set product to negative 1, and that can be our error case. Something like that. And then remind me to do some comments. Let's do that. So make sure is greater than 0. Make sure the input is greater than 0. If it's not, just make the result negative 1 so that we never do silly things. All right? So do one or the other of those options. So if n is less than or equal to 0, I guess. Because when it is 0, it's also a problem, right? So if it's less than 0 or equal to 0, that's getting a little ugly, but that's okay. If n is less than 0 or n is equal to 0, then, oh, sorry, I did the true case. That's actually easier, isn't it? If n is greater than 0, then we can do all these things. That's much better. I messed up the case I thought I was in. So yeah, when this is true, we want it to do the right thing. So we're in the right case if n is greater than 0. So if n is greater than 0, then do this process that will eventually end because we know it's greater than 0. Otherwise, set product to negative 1, some special dummy value that won't cause us to fail, right? And so here are our little tests. I'll click on them. Yay, test with 4 passed. And now, test with negative 42 passed because we got back a product of negative 1. Okay? Any questions about that idea? The idea of testing. Coming up with what should happen. Trying out a bunch of edge cases, some weird things. Okay? And before I forget, I will save this. Cool. So I will give it to you later. So any questions about that before I give you your next essay? Okay. So this one will be due week 12, so a 2-week essay. This is a longer one, so that's why I'm giving you 2 weeks. This should be fun. Historically, it has been, so hopefully it still is. What I would like you to do for this essay is definitely read all these requirements. There are quite a few requirements, but it will be fun nonetheless, I promise. So you're going to end up finding 5 different fallacies on social media websites, because there's plenty of them all over the place. Okay, so here are my directions. Definitely read through these, make sure you're following them. I don't want you to lose points for no good reason. So for this essay, you're going to go on the internet, wherever you like to go. Go on Twitter, go on Facebook. There's plenty of fallacies all over the place, right? Go on Reddit. You are going to find 5 fallacies in arguments posted on social media. Okay? There's plenty of them to find, don't worry. There are more fallacies than we talked about in class, so here's a link to Wikipedia, a list of fallacies. Usually informal fallacies are the ones that you find in arguments. So look through this list. There's plenty of them to discover. I just want you to notice them. And you're going to find some. So you're welcome to find any of those fallacies on the list or from class. If you'd like, you can pick topics about computer science issues, but you don't have to. Just find something. Politics are quite easy, right? The Russia conflict, also probably quite easy to find fallacies about those topics. So if you'd like to find some computer science topics, here are some hot ideas. But here is how I want you to write your essay. So this is your longest essay yet, because there's a lot of things that you'll copy and paste, right? You're going to find arguments and you'll quote them. So that should eat up a bit of these words. But that is the word limit, 1,000 words for this one. And here's the structure. I would like you to write like a normal essay, right? Even though you're finding a bunch of different fallacies. So have an intro paragraph, have a conclusion paragraph, as you should. And then in the middle, as many as you would like, but at least 5 paragraphs containing the following. So I want you to find a post on social media, quote it, and then talk about why it contains a fallacy. Okay, and tell me the name of that fallacy. Okay, that is essentially the idea. Any questions about what I'm asking you to do? Go on the internet and find people arguing in the wrong way. Okay, and then finally, my last requirement is, like I'm sure you've been on the internet before, so you know that it's very easy to find people just making fun of each other, and those are ad hominem fallacies. Those are very easy to find, so I'm not allowing you to use more than 2 of those out of your 5 total fallacies. Okay, that's all. So 5 fallacies total you must find. Tell me their name, analyze them, tell me why they're that particular fallacy. Tell me why people were wrong on the internet. Okay? Any questions about that? That's probably the most in-depth that I've gone into an essay, but this is an important structure that I want you to follow. Okay? So yeah, this will be due in 2 weeks, and if you have no questions, that is all that I have for you.